Welcome back, Algebra II students. This is the recording for section 7.3. Again, just a reminder, this is completely voluntary, but I will have all of this posted for you guys if you so choose. So last time in section 7.2, we talked about arithmetic sequences and series. Today, we're talking about geometric sequences and series. Now, you might be wondering what the difference is. Arithmetic, if you remember, had a common difference between the subsequent terms. So to get from term 1 to term 2, you'd like add 4. And then from 2 to 3, you'd add 4. From 3 to 4, you'd add 4. In a geometric sequence, we are talking about having a common ratio. So a common ratio means you're going to be multiplying by some number instead of adding or subtracting some number, okay, like we did with arithmetic. So one thing I want to point out really quickly is this formula right here has a misprint, and it won't let me fix it since this is a PDF file. We don't have the software for that, but this should be a sub 1 times r to the n minus 1. Okay, so please make that change. So let me write it again beside it. This should be a sub n equals a sub 1 times r to the n minus 1. Okay, a sub 1, not a sub n there inside the formula. So here's what the formula should look like. Okay, again, that's a misprint on the study guide through our curriculum. So anyway, so that's the formula. Now, let's kind of do a blast from the past. Again, last time we talked about arithmetic. Okay, if you remember the arithmetic sequence, the formula was a sub n equals a sub 1 plus n minus 1 times d. D was the common difference. Okay, now we're talking about having a common ratio from one term to the next. So you're multiplying by a constant r instead of adding or subtracting a d. Anyway, so we have a new formula for the nth term. And again, as last time we talked about, a series is when you add up so many terms of a sequence. Okay, so this is the proper formula for a series. Okay, so we have the proper formula for the nth term of a geometric sequence and the proper formula for the first n terms of a geometric series. Okay, so let's kind of dive in here. Look down here at these examples. It says identify geometric sequences. Tell whether the sequence is geometric. Now, here's one way to tell, and this is what they showed in your example. Some of these I think you can just see, but as you can tell here, to get from 4 to 8, we could either add 4 or multiply by 2. Okay, so if we multiply by 2, that's my little dot 2. To get from 8 to 16, multiply by 2. From 16 to 32, multiply by 2, and so on. So yes, this is a geometric sequence, and my r would be a 2. That would be my common ratio. Okay, the next one, if you look at it, again, from 4 to 8, you could multiply by 2 or add 4. 8 to 12, add 4 or multiply by some fraction. So this looks like it's a plus 4. Okay, 12 to 16 is plus 4. 16 to 20 is plus 4. Is that geometric? No, that would be arithmetic, where the d would be 4. Okay, that's what we covered last time in 7.2. So if you're adding or subtracting a number to get from one term to the next, it's arithmetic sequence. If you're multiplying, or I could say dividing, by a number to get from one term to the next, it is a geometric sequence. Okay, so that's the difference. Now, if you look at how they did it in their examples in the solution down here, they take the second term over the first term. 8 divided by 4 is 2. Then they take the third over the second, which is 16 divided by 8, which is also 2. The fourth over the third, which is also 2. The fifth over the fourth, which is also 2. Okay, and if you tell down here on part B, obviously that doesn't yield the same results. If we're looking for a ratio, we take the term to the right over the term to its immediate left. So the second over the first term, again, 8 over 4 gives me 2 again. But when we keep going, the third over the second term gives me 3 halves. The fourth over the third term gives me 4 thirds. The fifth over the fourth term gives me 5 fourths. Not the same. Okay, so in order for it to be a geometric sequence, the R has to be constant. That's the ratio. So let's look at some of these. Tell whether the sequence is geometric. So again, a couple of different things I can see is as I go on number 1, as I go from 2 to 6, I can either add 4 or multiply by 3. Okay, so, but then if I look at the next term from 6 to 8, I multiply by 3 or add 12. Okay, well, obviously the adding thing isn't working out for me, but the multiplying is. I am multiplying by 3 each time to get to the next term. So 6 over 2 is 3, 18 over 6 is 3, 54 over 18 is 3. So yes, that is a geometric sequence, and my R would be 3. Okay, so when in doubt, if you don't see the ratio, do the fraction thing, the second over the first term, the third over the second term, the fourth over the third term, and do the ratio thing. If not, some of them, like I said, you can just see. Same thing here with the next one. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. So I think we can safely say that my R is 3 again, and that's a yes. Okay, the next one, is there a multiplier that I use to get from one term to the next? No. Okay, this would be plus 4 if you see that. 7 plus 4 is 11. 11 plus 4 is 15. So this is a no, and in this case, it would be an arithmetic sequence, and my common difference would be 4. The last one here, number 4. Again, to get from one term to the next, 1 to 4 to 16 to 64, it looks like they're all multiples of 4. Okay, but notice they're also changing signs. So actually, it looks like this is multiplied by -4. Okay, multiplied by -4 and so on. And we can test that out. -4 over 1 is -4. 16 over -4 is -4. -64 over 16, and poke that in a calculator, -4, and so on and so forth. So this would be another yes, okay, and my R would be -4. So just like my D could be a positive or negative when we were doing arithmetic sequences, we could add a number or subtract a number. Same thing with R. R could also be a positive or negative. Okay, a negative ratio obviously is going to change your signs every other time. Okay, hope that makes sense. Moving on to the back side here. Now, writing a rule for the nth term. Now we're going to use that formula, okay? And you'll notice here on the back side, they did get the formula correct here. Okay, so that's the formula for writing a rule. So what you need to know in order to use the rule is you need the first term of a sequence. Okay, you need the first term and you need the ratio. Those are the two things you have to have in order to use the rule formula. So if you're plugging it in the rule, that's it. You just plug it in. So let's look at these exercises for example 2 here. Write a rule for the nth term of the geometric sequence, then find, looks like a sub 7, okay? So find a sub 7. Now, if I look here at number 5, the first thing I've got to identify again is my a sub 1 term. That's pretty easy. That's just the first term of your sequence. And what's my ratio? What did I do to get from one term to the next? It looks like here my R is going to be a 6. I just multiplied by 6 to get from one term to the next. So all I'm doing is poking it in that formula. So a sub n is going to be 1 times 6 to the n minus 1. Or we could just say a sub n equals 6 to the n minus 1. We don't really need the 1 in front. Multiplying anything by 1 doesn't help us. Okay, so that's my rule. Now it says then find a sub 7. Well, what I have to do then is plug in a 7. So a sub 7 is 6 to the 7 minus 1 power, or 6 to the 6th power. What is 6 to the 6th power? If you poke that in your handy dandy calculator, okay, you get 46,656. Okay, 46,656. Okay, number 7, I'm going to go below here. Number 7, again, my 1/2 is obviously my a sub 1. That's my first term of the sequence. Now, what's my ratio? What did I multiply by to get to the next one each time? Looks like the 1s stayed across the top, but if you look at the bottoms, it looks like I'm multiplying by 2 each time. So that means my ratio is going to be 1/2. Okay, so then my rule here, a sub n is going to be 1/2 times my ratio of 1/2 to the n minus 1. There's nothing I can do to kind of simplify that. That's it. Now be careful when you've got fractions. Notice I put the second fraction, don't know if you can see me darkening this or not, I put that second fraction in parentheses. That n minus 1 exponent only applies to the ratio. It does not apply to the leading term. Okay, so that n minus 1 is only on that 1/2 that's in parentheses. Now, if I try to find a sub 7, so that is 1/2 times 1/2 to the 7 minus 1, or 6th power, right? 1/2 times 1/2 to the 6th power. Well, literally, I can poke that in my handy dandy calculator. 1/2 to the 6th power times 1/2, and I just poked it in a calculator, but I get 1/128. That's, of course, one of my dead spots on the board. Let me scroll up a little bit. Okay. There we go. So let's do number 8. I'm going to skip number 6 just for time. So number 8 here, of course, this is my a sub 1. Okay. What would my r be? Now, one thing that jumps out at me, from 2 to 6 is times 3. 6 to 18 times 3. 18 to 54 times 3. But the signs alternate. So again, my r is going to be a -3 then. Okay. So my rule, my a sub n is going to be 2 times -3, make sure that -3 gets in parentheses, to the n minus 1 power. That's my rule. Okay, that's pretty straightforward. But now my a sub 7, okay, my a sub 7 would be 2 times -3 to the 7 minus 1 power, or 2 times -3 to the 6th power. So again, make sure that negative, okay, gets in the parentheses. -3 to the 6th power times 2 is 1,458. Okay. All right, I hope that's helpful. Okay, now series. Okay, we've got our formula. Remember, let me remind you what our formula is from the front side of the study guide. Our formula for the sum of a series is S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. That whole thing in parentheses, okay? So it depends, again, the n is the number of terms you're adding up. That's where the n comes from. So you can always look in your rule here, in your summation notation here, and figure out what your r is and what your a sub 1 is. This, remember, has got to be your a sub 1. This has got to be your r. Okay, so that's how you pick out of the summation notation where your a1 and your r is. Okay, and that's based on our a sub n formula. So a sub 1 in front and r is usually in parentheses. So they just poked it in the formula. Okay, so again, notice my a sub 1 got substituted with 3. Okay, my r's got substituted with 2. Okay, and then n was the number of terms. The number of terms we're adding. Okay, let's jump down and do a couple of examples here. Okay, find the sum of the first n terms of the geometric series. So again, first thing I need to do is identify all the parts. This right here is going to be my n. This right here is my a sub 1. And this right here is my r. Okay, so then after I have all the pieces, I'm literally just poking it in the formula. So let me do it over here. The sum of the first 12 terms is 2 parenthesis 1 minus 4 to the 12th all over 1 minus 4 and then end parentheses. Again, I literally just poked that in a calculator. Be very careful when you're poking it in a calculator that you have the correct parentheses. Okay, check yourself here because I'm going to write the answer. So check yourself. You should get 11,184,810. My guess is if you did not get that, you didn't put parentheses in your calculator correctly. Okay, so if I'm putting in my calculator, I would probably put 2 parenthesis 1 minus 4 to the 12th parenthesis, end parenthesis I should say, divided by parenthesis 1 minus 4 parenthesis, and then another set of parentheses if I'm poking it in my calculator. Okay, because I'm taking 2 times the whole thing, but then I need to separate the numerator from the denominator. So I have to put separate parentheses around the top and then divided and then parentheses around the bottom. Okay, that's one way you can do it. Okay, number 10, let's identify all the parts here. So number 10, this is my n. Okay, this is my a1. This is my r. Okay, so I'm just poking it in the formula. So the sum of the first 9 terms is 1 parenthesis 1 minus 6 to the 9th over 1 minus 6 end parenthesis. And again, you don't really have to worry about the 1 out in front because obviously multiplying anything by 1 isn't going to change it. So bada bing, bada boom, you put that in your calculator, you get 2,015,539. Okay, now next one. Again, let's identify the pieces here. This is my n. This is my a1, first term. 1/2 is my r. Okay, so you're going to have to be even more careful when you poke this in a calculator. So the sum of my first 6 terms is going to be 10 times 1 minus 1/2 to the 6th power over 1 minus 1/2. Now, I didn't necessarily need the parentheses around the 1/2 on the bottom. You will need it around the 1/2 on the top because that 6th power applies to both the top and the bottom. Okay, depending on how you're poking it in your calculator, you don't want the calculator to think you're only putting the 6th power on just the top, which wouldn't change it. Actually, putting the 6th power on the bottom would be fine since the numerator is a 1, but you do have to be careful poking that in. Okay, so just check yourself. You should get 315 over 16. Now, that is the answer out of the back of the book. However, since this turns into a nice, neat, even decimal, I would also take this. Okay, I would take either one, but the book actually gives the fraction as the proper answer. Either one's fine. Okay, let's do some from practice A. And again, I'll post all these documents for you. Okay, so practice problems from practice A. Tell whether the sequence is geometric. Explain why or why not. I'm really not going to be, obviously I'm not grading these, but I'm not going to be looking too closely at the explanation because I think it's pretty self-explanatory. Either there's a common ratio or there's not. But say for number 1 here, to get from 2 to 4, we're multiplying times 2. 4 to 8, multiplying times 2. 8 to 16 times 2. 16 to 32 times 2. So I would say this is a big fat yes, and my R is 2. Didn't really tell me to identify my R, but I think it kind of goes without saying. Now, number 4, I'm going to kind of go down. I'm just going to kind of do random ones of these. You all can do the ones that are left. Number 4, to get from 16 to 8, couple of different things. I could either subtract 8 or I could multiply by 1/2. Well, subtracting 8 would be an arithmetic, okay, difference. But the multiply by 1/2 may work. So let's check out the next one. To get from 8 to 2, I would like subtract 6 or multiply by 1/4. So right off the bat, I don't have anything in common. Okay, my ratios are not the same. So this is a big fat no. Okay, no common ratio, no common difference. Number 5, so to get from 25 to 5, and again, we can actually, let me just check this one. Let's do the way that, so if I have 5 over 25, that reduces to 1/5. If I have 1 over 5, of course, that gives me 1/5. If I have 1/5 over 1, again, that's 1/5. So what do we notice here? All of these have a ratio. This would be a yes. My ratio would be 1/5. Same thing as dividing by 5 is the ratio multiplying by 1/5. Okay, same thing. Okay, 7 through 9, it says write a rule for the nth term of the geometric sequence, then find a sub 6. So I'm just going to do the first one here. Now again, to write the rule, you need to know the first term and you need to know the ratio. So first term, of course, here's my A1. My ratio looks like, again, I'm multiplying by 2. Okay, so my ratio, A sub n, equals my first term, remember our formula, first term is A1 times the ratio to the n minus 1 power. So this would be my rule, okay? And then, and you can either put the 2 in parentheses, or since it's not an ugly fraction or anything, I just use the dot. Either way is fine. Then the 6th term, of course, would be 4 times 2 to the 6 minus 1, which is 4 times 2 to the 5th. Well, 2 to the 5th, if you all remember, is 32 times 4. That would give us 128. Okay? So got the rule and got the 6th term. Okay, now moving right along. Now, graphing. If you remember, when you go to graph these, your first term of your ordered pair is just the number of the term, like the first term, the second term, the third term. So the first term is going to have x equals 1. The second term is going to have x equals 2. The third term is going to have x equals 3, and so on. Okay, so write a rule for the nth term. Let's do that first. So I would have a sub n equals 1 times 2 to the n minus 1. So we don't really need the 1 anymore. So this would be my rule, okay? So now I've got to find a sub 1 through a sub 5. So a sub 1 would give me 1 comma whatever. A sub 2 would give me 2 comma whatever. We'll go back and fill these in. A sub 3 would be 3 comma whatever. A sub 4 would be 4 comma whatever. A sub 5 would give me 5 comma whatever. So again, your x value of your ordered pair comes from the number of term that you're finding. So first term, okay, well, this is 2 to the 1 minus 1 power. Well, 2 to the 0 power is just 1. Anything to the 0 power is 1, right? Actually, let me do this in a different color. So the second term would be 2 to the 2 minus 1. Well, 2 to the first is just 2. Okay. The third term would be 2 to the 3 minus 1, which is 2 squared, which is 4. Again, if our ratio is 2, what that means is we're doubling the y value. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, that's the pattern. So now let's plot those points. So 1, 1. Now, I hate this. You all know this about me. The n, if you will, okay, our x-axis count by ones. Our y-axis, if you can tell, counts by threes. So this counts by ones, this counts by threes. That drives me crazy, but whatever. So 1, 1 would be about right there. 2, 2, 3, 4, 4, 8, and 5, let's see, 3, 6, 9, 12, 15. So it'd be right about there. So 3 or 5, sorry, 16. Those would be my ordered pairs. That's what they're looking for. Okay, moving on down. Write a rule for the nth term of the geometric sequence that has the 2 given terms. Now, we're going to start off easy here with number 13. First of all, number 13, remember, to find the rule, you need a sub 1 and r. That's what you need to find in order to write the rule. Okay, well, we've got our a sub 1 here. Okay, got a sub 1. And my r, since 4 times 3 is 12, then that means my r on this first one is going to be a 3. That's easy enough to see. So then if I'm writing my rule, so then my rule here is a sub n equals 4 times 3 to the n minus 1. That would be my rule for number 13. Okay, 4 times 3 to the n minus 1. Now, that one was super easy. Let's do one that isn't so easy. Okay, we're going to do number 15 together, and it's going to take a little room. So we're going to do it next page. Okay, so I'm going to add a page of notes here. We're going to do it on the next page. So let me add a piece of paper here, get a blank spot, and here we go. So on number 15, we had what they gave us was a sub 3 is negative 32, and a sub 6 was negative 2048. Now, I don't know about you guys, but I probably can't just look at that and see what's going on. Because again, what we need in order to find the rule, we need, if you remember, we need a sub 1 and r. That's what we need, is a sub 1 and r. Well, we don't have either one of those two things. Okay, so we're actually going to build a system of equations here. Okay, so hang tight. So using this first one, if I use the pattern for the rule, okay, now remember my pattern for the rule, let me just remind you, okay, My pattern for the rule is a sub n equals a sub 1 times r to the n minus 1. Okay, so we're going to use that rule pattern here, or rule formula, maybe I should have said. And a sub 3 is going to equal a sub 1 times r to the 3 minus 1 power. Okay, well, a sub 3 is negative 32. Now I'm substituting in, equals a sub 1 times r squared. Okay, I am going to solve that for a sub 1. Okay, if I solve that for a sub 1, then a sub 1 equals negative 32 over r squared. Okay, now that's just kind of an intermediate step. Okay, now let's go over to the a sub 6. Okay, I'm going to do the same thing there. So a sub 6 is going to equal a sub 1 times r to the 6 minus 1 power. Well, a sub 6's value is negative 2048 equals a sub 1 times r to the 5th. Okay, now I am literally going to take this value that I found for a sub 1 and plug it into here. I'm going to substitute. Okay, I'm going to substitute in the a sub 1 value. Okay, so that's going to give me negative 2048 equals negative 32 over r squared times r to the 5th. Okay, I just substituted it in. Now, what can you tell me about the r's? These two r's will cancel with two of these and leave me with 3, right? So now I have negative 2048 equals negative 32 r cubed. Now, I got to solve for r. So first, I'm going to divide off the negative 32. So r cubed is negative 2048 divided by negative 32. Again, hitting a little dead spot here, so let me scroll. So negative 2048 divided by negative 32. Let me try to fill in the dead spots here. Is, sorry, positive 64. Actually, let me rewrite that. We don't need the plus sign. And I'm going to scroll. So if r cubed is 64, how do I solve for r? Take the cubed root of both sides. Okay, if I cubed root both sides, okay, and I don't have to worry about plus or minus on an odd root, if you remember. So then this gives me that r is 4. Okay, well, if r is 4, what is a sub 1? Because remember, I've got to have a sub 1 and r. Well, poke it back in. Substitute it back. So a sub 1 equals negative 32 over r squared, which is negative 32 over 4 squared, which is negative 32 over 16, or negative 2. So negative 2 equals a sub 1. Okay, substituted and then substituted back. So now that I know what r is and a sub 1 is, let me go back to the other page. Okay, so now on number 15, we found out that r equals 4 and a1 is negative 2. That's what we found. So that means our pattern is a sub n equals negative 2 times 4 to the n minus 1. Okay, I hope that helps. I hope that gives you enough notes there for some subsequent ones that don't start with a 1. Now, find the sum of the geometric series. We are literally just using the formula. Okay, once again, we got to identify all the pieces. So this is my n. This is my A1. This is my R. Okay, so the first 6 terms of the series equals 2 times 1 minus 2 to the 6th over 1 minus 2. And again, I just poked that in a calculator. Again, be careful of your parentheses, and you should get 126. Okay? Now, I wanted to jump and do number 24 since it had kind of an ugly fraction in it. Again, this is my n. This is my A1. That's my R. Okay? So, my sum of the first 6 terms here would be 1,000 and then parenthesis 1 minus 4/5 to the 6th power. Again, be very careful when you poke that in a calculator with parentheses. Over 1 minus 4/5 on the bottom. Okay, I poked that in a calculator and I got 3,689.28. You'll definitely want to try that yourself to make sure you're putting it in the calculator correctly with the right parentheses where they need to go. So again, be very careful in calculator work. Now, 25. Last one, I'm just going to help you get started here on part A. It says a production or a company plans to increase production by a product of 10% each year. Now, a couple of things I want to point out. This is an increase of 10%. Okay? An increase of 10% means you're going to continue to do what you always did, that's 100%, and then you're going to add 10% to that. So that is 100%, which is your normal productivity, plus 10%. Well, 100% plus 10% is obviously 110%, which is 1.1 as a decimal. Okay, that would be your ratio. So an increase of 10% means 100%, which is your normal output, plus an additional 10%. That's 110% or 1.1. So my big hint or tip here, this right here would be your A1 because it would produce 70,000 units in year 1. So that's your A1. Your R is going to be 1.1. Okay, that was the increase of 10%. So that's my hint on those. Okay, so I'll leave the rest to you. Again, this will all be posted along with the key if you want to check yourself, but this concludes section 7.3.